The first period of these inland seas, these seas coming in and out, the movement of water is obviously carrying things with it and laying down layers, whether by sea or streams in the region. Some examples of these, the stones from, or the rocks from this period are found in Pictured Rocks National Lakeshore, which is for the middle Cambrian. We're also seeing Jacobsville sandstone, which you see along the south shore of Lake Superior quite a bit, buildings being made of that really red sandstone. So those are kind of fun signs of places that we visit that have this evidence, you know, from this time period. It's also a period of time where there's lots and lots of simple life, and things like trilobites are found in these inland seas. In the Great Lakes, there's very little fossil record because of some of the stuff that happens later and some of the layering that happens on top of it. Some of these other periods will see some evidence of life in the region. This period of time, the Ordovician, is a period of, again, inland seas. It's a really long period of time. We're seeing lots of different sedimentary rocks being deposited. This outcrop, sort of fuzzy that way, but you can see these layers that have been deposited and compacted. This outcrop is actually in Indiana, but it's from this time period here in our region. If you were to look at your little chart, throughout Minnesota, we're seeing things like limestones and some sandstones and shale in that general family of rocks being deposited, but we don't really see that here, around here. But you can find in these layers from this period of time lots and lots of different types of marine fossils. So not in a region per se, but in this time period, that's what's going on the continent. We are zooming like super fast through these big periods of time, like this is millions of years. The Silurian reefs, I think, are one of the coolest parts of the middle of the story here. We have shallow landlocked seas and these reef formations forming. You'll notice that here's the Michigan Basin again, here's Lake Michigan curving around. Lake Superior doesn't have evidence of these reefs, but you can find the fossilized reefs. Folks have excavated and found them. During this period of time, the sea level is changing dramatically, sort of up and down, but we have this inland body of water that's depositing these reef structures or systems, which makes our aquarists giddy with delight, because in this Origins exhibit, they might be able to do some reef stuff, which aquarists seem to really dig, these reef systems. So it's a pretty cool period of time now. We don't often think about reefs in the center of the continent here.
Is that the Petoskey stones? Formation of
The coral, yes.
That's from that time
I believe
period?
so. I don't know for sure. Does anyone know? But that would be my bet, because those are fossilized corals.
Oh, they are, but I just wonder if they're from that time period.
I imagine so, but I would not want to stake my life on it at this point. I'm sorry. There are definitely some like showing edges of my geology knowledge here. So I said I was going to talk about ancient life, but we can't mention the Devonian without talking about it being the age of fishes. Really, fish evolution kicks it up a notch in this period, and in our inland seas, again, in this period of time, lots and lots of inland oceans here. For everything from sort of the jawless fishes transforming into these huge school bus size armored fishes with incredible skull structure, but cartilage for the rest of them are found, would be found in our region. We do have fossilized remnants of the skulls, which is pretty cool. At this period of time, because we have inland seas kind of in and out, often, if you're familiar with sort of tidal zones, you often have lots of mud associated with areas that are more tidal in nature, and so some of these muds that were laid down are evidenced in the rock layer and metamorphosed into things like shale that you see as classic Devonian rocks. Okay, so the Carboniferous period is mentioned on some timelines. Other folks call it the Mississippian, the Pennsylvanian, and the Permian as kind of grouped together. The big thing for this time period in the Mississippian, the first part of the Carboniferous period, have major uplift, so the land is moving up and the seas are retreating, and we start to see lots of sediments eroded away. One of the things, this picture is not of the Great Lakes, but I thought it was a great way to illustrate in some ways the fact that we have layers, and in this one they're talking more about aquifers, so layers of water, but I liked just some of the disjointedness that you can see as the land along faults uplifts and changes, the layers get skewed, and that's part of the challenge in understanding what happened in our region is thinking about what might have caused those things and which layer sort of connects with which other layer. Sometimes as part of uplift you see buckling, so if you imagine like my paper, kind of creasing and folding, you'll see this happening also. So depending on which piece of the fold you've uncovered, it might tell you a different story. So kind of keeping everything in context, relative context to what happened before. So the first part of the Carboniferous period is really about uplift and those seas retreating. During this period of time is when the huge coal bands we see largely evidence of now in places like Pennsylvania and sort of the southeast, or I guess mid-Atlantic there. This is a period of time where you have this transition between marine environments and terrestrial environments kind of changing back and forth. We also see giant swamps during this period. That plant matter from those swamps gets compacted, and eventually turns into coal. During this period of time, we have major things moving and shaking on the East Coast. So the Appalachian Mountains kind of rising out of the surface. We see in this period some marine fossils also. Okay, so on this little diagram that I gave you, there's these big gaps where it says there's no record in Minnesota. Some folks in the Great Lakes call this the lost interval. There's basically, we don't know what happened. We can make guesses based on what's going around us, but there's no evidence here to really show us that. This is one of the periods of time where we're only getting evidence, again, through cores, and things like pollen might be found during this period of time. The Great Lakes are moving upward and, again, being subject to erosion, which is wiping away some of the record of what actually happened here. So we've talked a little bit about the fire part, the sea part, and now we'll talk a bit about the ice part of the story. The Pleistocene served out its great ice age. The most recent in time to us, there's sort of two sections of the Pleistocene, two parts. The most recent, the one we're in today, is really called the Holocene. The very, very tip, if your arm is geologic time, we're at the very, very tip of your fingernail right now, and all of this came before us. The glaciers, a glaciologist, I imagine, would argue, have had the most impact on our landscape. They really have shaped a lot of what we actually see today on the surface topography. A couple of things about glaciers and how they work. The big thing they do is push stuff somewhere else and erode the land. So they're picking things up from one place and depositing it somewhere else. The glaciers in this region are the evidence for glaciation in our region. Things like the topsoil is often different than the bedrock, and typically what you can see is as bedrock matures and erodes, you have this very clear connection between the bedrock and what you see in the layers above it. Sometimes it's very different because it's glacial till, things that have been deposited by glaciers somewhere new. Sometimes there's very little because it's been scraped away. And the other thing we see in our region are these evidence of glacial scouring, big chunks of ice scraping, maybe with the ice itself or with large boulders, huge aquarium-sized rocks. It's dragging across the landscape and scouring either the land away, these soil layers away, or the rock itself. You can see evidence of this if you're sort of local and thinking about taking school kids outside. Brighton Beach is a great place to actually see some of the scouring. If you look at a satellite map of the Northeast here in Minnesota, you can see some of that glacial scouring in the boundary waters with the shapes of the lakes sort of moving in one direction. The other thing, other evidence is that we have things like Lake Superior agates, which we sort of established are unique to our area, being deposited way far south of us where they couldn't possibly have formed. And so the glaciers were here, for sure. Some of the evidence of the different periods of glaciation that happened, folks think in this era scoured away by other glacial events. The most evidence is from the latest, the Wisconsinian, I can never say this, Wisconsin glacial event. And so most of our evidence comes from that period of time. Some of the, just to kind of point out, I thought this was one of the best diagrams of an esker I've ever seen. Places like, there's a great esker at Boulder Lake Environmental Learning Center that you can actually ski kind of along here. So as the glacier retreats, it's leaving things behind in different patterns, and we actually can see that in the landscape today. I think it's amazing to walk out with a geologist and have them just spot like an esker for 50 paces, where I'm like looking at what the trees are. But again, this ancient, you have these like river systems that are underneath the glaciers depositing debris. We've talked about sedimentation as one of the major processes. These pockets where you might have ice that pushes down, you scour it, and then the pockets fill up with water as the glacier retreats. In our region, the glaciers came and went and came and went and came and went. Several different lobes or fingers of ice moving across the land over time. And so it wasn't just one big glacier, it moved along and then it left. It was several different events.